Hi everyone, it's me Sherly, Faculty of Chemistry, Silver Hills Higher Secondary School. In this video, I am discussing displacement reaction for class 10. For that, let's prepare some copper sulfate solution. For that, take some copper sulfate in a beaker and add some water in it. Stir it well. The color of copper sulfate solution is blue. Take a zinc rod and dip in it and observe after some time. Wow, the color of the solution fades and it became colorless. Something happened there. Yes, zinc reacts with the copper sulfate solution. Zinc displaces copper from its solution. Copper is removed and the solution became zinc sulfate solution. It is colorless. That is why the blue color changes to colorless. And the equation we can be represented as Zn plus CuSO4 gives ZnSO4 plus Cu. Zinc and copper are the metals present here. Among these metals, which one is more reactive, zinc or copper? To find that, let us consider reactivity series. What is reactivity series? In this series, some metals are arranged in the descending order of their reactivity. Potassium comes first, which is most reactive, and gold comes least, which is less reactive. And hydrogen is also included in this series to compare the reactivity of the metals. The metals above hydrogen are reactive and the metals below hydrogen are less reactive. Now let us see the position of zinc and copper in this reactivity series. Zinc, it is above copper, means that zinc is more reactive than copper. Being more reactive, zinc displaces copper from its salt solution. That is, a more reactive metal can displace a less reactive metal from its salt solution. These type of reactions are called displacement reactions. See, displacement reaction. Metals with a low reactivity are displaced from their salt solution by the metals of high reactivity. Then let us see what is the chemistry in this displacement reaction. What are the chemical reactions taking place during a displacement reaction? You know that the process of donating electrons in chemical reaction are called oxidation, and the process of gaining electrons in chemical reaction are called reduction. Zinc is more reactive metal here than copper, so zinc loses electron. Each zinc atom loses 2 electrons. When an atom loses electron, it became positive ion. So let us see the reaction that is taking place for zinc. It loses 2 electrons. It can be represented as Zn gives Zn2 plus 2 electrons. Copper in copper sulfate solution exists in the form of copper ions. So these copper ions receive electrons. Each copper ion can gain 2 electrons and it can be represented as Cu2 plus 2 electrons gives Cu. So here both oxidation and reduction takes place. Zinc undergoes oxidation and copper undergoes reduction. In a chemical reaction, if both oxidation and reduction takes place simultaneously, it is called redox reaction. So displacement reaction is a redox reaction. Now let us consider some zinc sulfate solution. It's a colorless solution. Take a copper rod and dip in it. Observe after some time. Anything happened? Nothing. Nothing happened. It shows that there is no reaction. You know, copper is less reactive than zinc. So copper can't displace zinc from its salt solution. So there is no displacement there. Let's consider one more activity to explain this displacement reaction. For that, I considered 4 different solutions. That is zinc sulfate solution, ferrous sulfate solution, which is green in color, copper sulfate solution, blue colored, and silver nitrate solution. Dip a copper rod in each of these solutions. Can you say in which beaker displacement takes place? Let's analyze one by one. In the first case, copper is dipped in zinc sulfate solution. To compare the reactivity, we can take that reactivity series. Copper, it is less reactive than zinc, so copper can't displace zinc from its solution. So there is no displacement here. Let's take the second case, copper dipped in ferrous sulfate solution. Here the metals are copper and iron. See the position in the reactivity series, copper is below iron. So copper can't displace iron from its salt solution. There is also no displacement taking place there. Then in the third case, copper is dipped in copper sulfate solution, a metal dipped in its own salt solution. There is no reactivity difference, so reaction won't take place. And in the fourth case, copper is dipped in silver nitrate solution. Let's see the position of copper and silver in the reactivity series. Copper, it is above silver, shows that copper is more reactive than silver. Being more reactive, copper displaces silver from its salt solution. The displacement takes place. Which metal undergoes oxidation? Copper, no doubt it's copper. And which undergoes reduction? Yeah, the least reactive metal, that is silver. And let us try to write its reaction, oxidation reaction. Copper undergoes oxidation, and it can be represented as copper gives, or copper is converted into copper ion Cu2 plus 2 electrons. It is donating 2 electrons, undergoes oxidation. And silver undergoes reduction. Silver ions receives 2 silver ions, receives 2 electrons and converted into silver atom. And that is, it can be represented as 2 Ag plus 2 electrons gives 2 Ag. That is, silver undergoes reduction by gaining electrons. Here both oxidation and reduction takes place, so it's a redox reaction. So displacement reaction is a redox reaction. So once again I remind you, that is, in a displacement reaction, a highly reactive metal can displace a low reactive metal from its salt solution. I hope you understood displacement reaction. Thank you, and let us meet again in another video.